So, the first most important part of this section is, again, what's a parallelogram?
Two sets of parallel lines.
Okay, two sets of opposite parallel lines. So it means that the opposite sides are congruent to each other. What do we know about the diagonals of a parallelogram? Do we know anything?
Opposite angles.
They could, well, yeah, they would intersect. And what?
Opposite angles are congruent.
Opposite angles are congruent. What else?
They bisect each
What do?
other. Diagonals.
No. Remember, that's a rhombus. So that's a special parallelogram, right? What else? Consecutive angles are 180, supplementary. Okay, so all those things that we've talked about so far, you still got to remember. Now, when we talk about the area of a parallelogram, the most important thing is to realize or find the base. So, what's the base of a parallelogram? Well, again, everybody remember what my parallelogram looks like? And they really should then put little, how do I show that they're parallel again? My little arrows, right? And then we can show this one too. Okay? So, how do I know what the base is? Is the base what it's always sitting on?
No.
Is the base this side over here? Could honestly be any of them, right? So that's where you got to kind of think about when they talk about finding the base, because that's going to be a part of our formula. When they say find the base, you're going to look for a right angle. Wherever the right angle is going to be the two sides that you're going to use to figure out what your base is. So again, to show me that I have a right angle, I would expect to have a what?
Box.
A box. Okay, so when you do this, what has to be true about the two sides that make that box? They have to be what to each other? Perpendicular, right? And so, if I had this regular parallelogram right here, is it possible to have a box in that?
No.
No, right? So, what we're looking for is, we're looking for a right angle, but this is going to be found by, you also need to find a height. So the height of something is what?
How tall?
How tall it is, right? So in our particular case here, how could we describe a height of a parallelogram?
Base to top.
The what?
Base to the top.
The-
straight.
The base to the top. Okay, so, but what's the base?
From
Let's just
parallel
make it
parallel side to parallel side.
Parallel side to parallel side. So if I came over here and I drew a line like this, is that a height?
No. You're gonna go from the
Why not?
vertex to the base.
Okay, so I'm gonna go where?
Vertex to base.
Okay, so do I have to always go from a vertex?
No, just that's all the shape was.
Yeah.
No.
No, you
This
can
case.
So if we went from a vertex to the base, we would call that a what instead of a height?
Altitude.
An altitude. Okay? So is a height always an altitude?
Yes.
Yes, right? So if we drew this line right here, everybody okay with that being a height as long as it's straight? And we can definitely say it's a height by doing what?
Put in the box.
Put in the box, right? Now, here's the next question. Can I draw this dash line right there? And would you consider that dash line and that straight line right there the same height?
Yes.
So could the dash line be considered the height of the parallelogram?
Yes.
Yeah, as long as I did this?
Yes.
Okay, now what about this?
Yes.
Yes.
Is that still a height?
Yes.
Okay? So a height can be inside or outside. Of the figure. You just got to make sure that you have that box. Okay? So we don't have to go necessarily from a vertex. We're looking for a height. So then, remember now, if I'm looking for the area of something, what's that mean?
The inside.
The amount of, right? So the area of anything is really the amount of, do we want to say space?
No, that's fine. Units.
So how are you going to think about area? So they say the number of square units contained in the interior of a figure. Amount of square units. So again, this is a big part of this. That your answer should be square units. Everybody understand what that means? Amount of square units in the interior of a shape. So when we say square units, remember my label at the end should just be squared. Right? Doesn't matter what we're talking about, it just needs to be squared. And why is that?
Because it's a box. It's like a 1 meter box next to another 1 meter box.
Okay? So why does it end up being squared? Because what do you
That's
do?
how many, like,
Oh, that's
squares are
on the
inside.
other side of it, wouldn't it? There's like, that's showing the image.
No.
So that's how many squares are inside of it. It's like, let's go if it's like square inches.
How many squares
That's how many
fit in
inches.
It takes from one
Like,
side.
that's how many squares that are 1 inch by 1 inch inside of it.
Yeah.
I don't want to say no necessarily because I think you're on the right track, but. So, hold that thought. If I asked you what the formula to find the area of a parallelogram, you would say what? Length times width. Or if we talk about what we were talking about over here, instead of length times width, we would actually say what? So we're going to say A equals. Now here's a huge thing for this chapter. And this is going to upset some of you because I'm going to count it wrong, but I'm telling you right now. So everybody listening, the letter that you draw is really important. Yeah. Those of you that don't write very well, it's very important. So this has to be capital A because we're going to have a lowercase a here at the end of this chapter, and little a and capital A are two totally different things. Okay, so it's really important. So when we write this, we want to say capital A is equal to lowercase b times lowercase h. Again, lowercase b. B is going to change here, okay? H is still just H. So, area equals the base of the parallelogram times the height of the parallelogram. So again now, let's say this now. Why is my answer squared? Because what did I do with my two things that I was using to do my area? I'm multiplying, right? So if I take something times something else, that's the same thing. If I take inches times inches, it becomes inches squared. That's why it's squared. Okay? Unlike perimeter, when we're adding, we take inches plus inches, and we just get more inches. That makes sense? So again now, the base might be this other side, but it's the base and the height. Now here's the question. If I'm looking at this shape right here, and they give me the height as this little extra on the outside, when I'm doing my base and my height, do I include this little part for my base? No. That's really important, okay? So we're going to do base times height. So the other thing that could come back into play are trigonometry or special right triangles. Okay, so if I came back here and I drew this right here and told you that this was, and then if I gave you a 45-degree angle right here, then I know in this little triangle, I know it doesn't look like it because I didn't draw it right. Remember, I can have this 45-degree right triangle too. And so, if you don't remember those kind of things, then you got to just use regular trigonometry in some of this stuff. So you're going to use either or. But if you want to go back and use the special right triangles, what are my two special right triangles? Obviously 45, 45, 90, and then the other one was what?
30, 60, 90.
30, 60, 90. Now, don't say this one out loud, let everybody have a chance to think. What are the ratio of the sides in a 45, 45, 90?
1, 1, 2.
Jesus.
Oh.
Go ahead, Gabriel.
1, 1, 2,
1, 1, what?
2,
1, 1, what?
square root of 2.
Square root of 2. Okay? What is the square root of 2 always going to be? The hypotenuse. Okay? What are the ratios? Do not say it out loud, let everybody try to think for 30, 60, 90. Everybody got an answer? What?
1 square root of 3, 2.
1, square root of 3, and 2. Remember, we want to line them up, right? Why is 2 across from 90? Because 2 is actually bigger than the square root of 3. So you might use this, or you might use trigonometry. Remember trigonometry, we're going to use this word. So again, you can always use trigonometry, as long as you have a right triangle. Okay? If you need any help with this, go ask the 7th graders. They just did this. Okay? Not to make you feel bad. Okay? So, questions here. We'll go over a couple of examples in a little bit. So, the most important part of this that we're getting at is I have to find my base and my height, and the base and the height come from where we make that right angle. Okay? So, from there then we automatically go to the area of a triangle. Why?
Because we just did triangles.
Based on height.
Same
Also,
thing.
2 triangles and 1 square.
Right, because basically we can make a triangle from our special parallelogram, which is a rectangle, right? If I draw that rectangle, basically I'm going to make a triangle by drawing my diagonal. And when I do that, then I can erase the rest of my rectangle, right? So I get my triangle, and again, I'm concentrating on where my base and my height are, but from my rectangle, what portion of my rectangle am I using? Half of it. So the area equals 1/2 base times height. Okay? But again, that's essentially why that happens, because I can take that rectangle and just cut it in half. But again, we're looking for where it makes that right angle. So the ones that we will look at for sure sometime, I don't know if we'll get to it today, is if I have this kind of triangle. Is that a right triangle? No. So basically what they're showing is then that you would extend your triangle to the outside of it. And again now, you just have to make sure that when you do your base and your height, if they give you numbers all over this, let's just say that this is 14, this is, I don't know, 15, and this is 20, and then they give you that this is 16. Just realize that I'm not using all those numbers. Okay, if I'm asked to find the area of this, I want the base and the height. So I'm looking at what two sides make up that right angle, which would be these two sides. But again, remember, if they give you this little section right here, and let's just say they say that this is another 5, you don't use that 5, you're just going to use 14 because that's the base, and then the height of 16. The 15 and the 20 are just trying to confuse you, basically.
The base is underneath.
A trapezoid. So first off, don't say anything out loud. We're thinking about trapezoids. So first off, how could you describe a trapezoid? Everybody got kind of a definition in here at the back of your mind? Obviously, it's a quadrilateral, right? And then we would say what?
2 slanted sides.
What?
2 slanted sides.
Not necessarily.
One set
Two
parallel ones.
One set of parallel sides. The only reason I didn't say what, not necessarily the Jackson, is this, right? Normally, yes, Jax, we're thinking this, right? That being a trapezoid. But remember, this also could be a trapezoid. And then realistically, that side's not slanted. Okay, so that's still, so Geom's, when he says that we have one set of parallel sides, that was actually true, okay? Did we know anything else about a trapezoid?
The angles do something.
What happens, what about consecutive angles again?
Oh, yeah.
180.
180 degrees are supplementary, right? Not a big thing in this though, okay? So if you think about this in a sense, we're again trying to figure out the area, right? So what do you think we need in order to have an area? What did we need yesterday in order to find the area? We needed a base and a height, right? So again, the height was found by looking for that what?
Right.
The right angle, the box. Okay, so in the top one, do I have a height? Not necessarily right now, right? So my height, a lot of the times in the trapezoid, is going to be that dashed line that we showed yesterday. Either coming from a vertex, or even right down the middle, or you could realistically say that you could draw this, and that would be your height out there. Okay? But we still need a height, right? But in our case, with a trapezoid, how many bases do I really have?
2.
I really have two, right? No matter if we're looking at the one on top that Jax was thinking about or the one on the bottom that I said, right? So we have to have a combination of those two bases, right? So my area for a trapezoid, again, make sure that it's capital A, because capital A is going to be different than little a that we're going to talk about Monday, okay? Is equal to base times height, but how many bases do I have?
2.
So, I gotta have both of my bases. But what do you think we're gonna do with the two bases? We're gonna add them together and divide by 2. So basically, we're taking the average of the bases times, bless you, the height. So there's multiple different ways of writing this, honestly, right? Sometimes people write it as 1/2 B1 plus B2 times H. Those are the same thing, right? Okay? And it doesn't really matter when you divide. Okay? Remember, when I write this, I'm still dividing by 2 or multiplying by 1/2. Okay? So, you just got to find that height again where they give you that box. All right? Questions there? So that's basically all they really talk about as in a trapezoid. So my next shape is a rhombus. And then we're also going to talk about a kite today. So, what's a rhombus?
4 sides.
Yes, it is a quadrilateral, you're right. But what's special about a rhombus? 4 equal sides, right? So remember when we drew a rhombus, it was kind of like a what?
Square.
It was kind of like, oh, that was
Diamond.
it's kind of like a diamond, right?
Yeah.
Well, that's really bad too. That was like a kite. So what did I do with my square?
Stretched it.
Stretched it, right? Why can't I draw this today?
I'm not sure.
Okay.
Draw the size
That's
of
all
the
right.
square.
Kind of, I don't know if it's true, but. Okay, so here's again now the thing. It's quadrilateral with 4 congruent sides. Okay, so now what else? Don't say it out loud, let everybody think for a second. There's special things about the diagonals. So again, everybody understand what the diagonals are? The diagonals are these 2 lines right here. So the first question is, are the diagonals congruent?
No.
No, because if it's truly a square that's kind of pushed out on one side, right? When I push on these two corners elongate kind of, so it gets farther and farther apart. So what happens to the diagonals of them? They bisect each other. And what else? They're perpendicular. So they got to have that box, right? So if I realistically looked at this, would you say that every single time that I drew one of these, it would work out that this triangle right here ends up being the same thing as this triangle?
Yeah.
And this triangle? And this triangle? Gabriel says no. Why not, Gabriel? remember one of the ways of showing that triangles were congruent was side, side, side? Remember that? Okay, so realistically, if I come back and instead of my outside ones, I draw 3 segments, because I really don't know if like this was congruent to that, so I really needed them to be different. But notice, like this triangle right here, I have a 3, 2, 1 side, and then over here I have 3, 2, 1, and over here and over here. So all of those triangles on the inside are actually the exact same triangles. Everybody okay with that? So what happens in the middle here? Well, what happens in the middle here is that I actually drew my box because he said that they're perpendicular, right? So besides my triangles being the same, I also know that they're all right triangles, right? So if they're right triangles, we may be able to use Pythagorean theorem, we may be able to use trigonometry, we may be able to use special right triangles like we talked about yesterday. Okay, so this leads us to, let's draw this shape first, because these two get tied together. So what's a kite?
Like,
Looks like a kite.
Okay, but we're going old school kites, right? Old school kites, because now anything basically gets turned into a kite. So what was the definition of a kite? It was a quadrilateral with what?
2 sets of
Congruent lines.
congruent segments. Sorry.
Congruent segments.
You need one more word in there.
Symmetrical.
2 sets of
There's the angle in between.
blank congruent sides. Begins with the C also.
Consecutive.
Consecutive, right? So they had to be back to back, remember? So when we say back to back, these 2 sides right here were congruent, and then these 2 sides right here were congruent.
And then the
Remember that?
The angles congruent.
And then what angles were congruent?
Between.
Okay, the top and the bottom in this case, or the left and the right?
Right.
It's always the ones that were in between, right? So this was congruent to that. And then when we drew our diagonals, what happened with our diagonals again?
Perpendicular.
They're perpendicular still. That's why I said they're kind of like this over here. So realistically, would you say that we had these 2 triangles would be the same again?
Yes.
And how about these 2 triangles?
Yes.
Okay, so we could still use some version of Pythagorean theorem again, maybe trigonometry again, or special right triangles, right? Because it's a right triangle. Okay, obviously the top 2 and the bottom 2 aren't the same thing. Okay, but why we show these 2 together is we're going to talk about the diagonals. So the area here for both of these, the rhombus and the kite, are going to be revolve around those diagonals. So we're going to differentiate the diagonals. We're going to show diagonals as lowercase d. But we're going to differentiate them by saying d sub 1 and d sub 2. Again, those are just subscripts, right? So we're just showing the difference between the 2. Okay? So d sub 1, d sub 2, and then you're going to divide by 2. So you're going to multiply the 2 diagonals together, and then you're going to divide by 2. Or we could say, what again? 1/2 d1 d2. Okay?
Can you scale the D1?
So again, if you don't like this right here, then you could just say 1/2 d1 d2. Ladies and gentlemen, I'm telling you straight up right now, you will have to do this for both the quizzes and the tests to write down all those formulas. Okay, so on the test, the first 15 questions are all about formulas. I think so.
Points or questions?
15 consecutive questions are all about formulas.
Well, we've only done like 2. How many
Four.
more? 3, 4.
Is the test many problems?
We did 4 equations. There's still.
How do you figure 4?
We
Well,
have.
we did triangle and parallelogram. Now we did trapezoid and rhombus and kite. So
That's only 4 formulas.
4 out of 15, bro.
I don't know, maybe I lied.
We have a lot.
There's a lot. But we still got circles. We still got a couple things in circles to talk about. We still got polygons, and we still got a couple others. There's probably 10.
Oh my gosh.
Okay? And that's what you have to do. So again, remember when everybody says, well, I can't study for math? They're studying right there. Okay? Knowing your equations. Okay? All right, so questions here
Sorry.
with the formulas.
No.
All right, now we're up here.
Camden, Robert Park, please.
Don't be your 18 on maybe
Yeah, this is both sections.
All
Alright, so we go back to the first section now. Again, concentrate here. Here's my first problem. So again, as we're going through this, I want you all to start thinking about it every single time. Hey, what's the formula I would use? Don't say anything out loud. Right here, what's my formula for a parallelogram? Everybody should start thinking about that. Okay? And again, the most important part of this is the kind of letter you use. Meaning capital letter versus lowercase letter. Okay? So, first things first. Notice the question. The question has two questions, really, right?
Yeah.
So you better have at least two answers. Right? Everybody understand what we mean by the perimeter? And we can find the perimeter always because why? Well, yeah, but in a parallelogram we can always find it because my opposite sides are what again? Congruent. So why the heck did they give me 12 inches?
Oh my god.
Because I need the what? I gotta have the height. Right? I need a height.
That's the height.
Is that the height? This is the height, Geom.
No, it's not the height, but I need a height. Right? So I need to find the dashed line.
Oh, I see.
Okay? So if they give me the 12, then I'm going to use the 12 and what else in what formula?
20 in Pythagorean.
In Pythagorean theorem because it's a right triangle, right? So anybody know what's 400 minus 144?
Pieces on.
366.
400 minus 144.
256.
Yeah.
What's the square root of 256?
13. 14. 16.
No.
16. So 16 is my what? Concentrate. 16 is my height. So here's the question. This is important now. Don't say anything out loud. What is my base and what is my height for my formula, which is base times height? Everybody got an answer? What's my base?
32.
32, right? The two sides that the box actually touches are my base times height. So we're going to take a 32 times what?
16.
16 is my what? What's the label for area? Inches squared. So then when I go back to perimeter, I'm going to take what and add what four things together?
32, 20.
Then we basically throw out the 12. But my label for perimeter is what?
Just inches.
Just inches. Okay? Make sense to everybody? Do you need to see any of the math? So obviously, you probably did these kind of things, right? A parallelogram way back in what, 7th grade? Honestly?
Probably 5th.
Maybe 5th grade, right? But now, we didn't know about the Pythagorean theorem to get this height. So that's what the new things are, right? We're just putting new things into the problems. Nothing there.
Can you stop looking at the answers?
Gabriel, are you cheating again? Alright, here's the next one. So, when they give you this problem right here, again, I need my base and my height. So, here's the problem. What is 12?
The whole thing.
The whole thing. Okay, so, how do I find H? I can either use special right triangles, or if you don't like special right triangles, then I have to go back and use what? Regular trigonometry, SOHCAHTOA, right? Okay? So, what?
How would you do that with trigonometry?
If I'm going to do this with trigonometry, I'm basically asking myself, what relationship does this angle have with this side and this 9 side?
Opposite.
Opposite over what?
Hypotenuse.
So what's opposite over hypotenuse?
Sine.
Sine. So I do sine of 45 is equal to h over 9. If I'm going to do special right triangles, what do I do with 9 to get to h? Divide by the square root of 2. Okay, so it's 9 divided by the square root of 2. Now, obviously, the biggest thing that you have to convince yourself is what in this figure? It's not drawn right. Because if this is 45 degrees right here, that means this is 45 degrees, and that means this height and this length right here are actually what? The same. And there's no way if you would look at it that it would be the same. Okay, so you just got to convince yourself. So you need to see the math.
Sure.
Yes?
Scotty does.
So we're going to say, let me write it up here, it's easier. So we're going to say the sine, we can either do it as the sine of 45 degrees is equal to h over 9. And then when 9's on the bottom, what do we do with these two things? We just multiply them, right? That should be the h. If we do special right triangles, then we have this, right? 45 and 9. So we would have had, what? 1 square root of 2?
Yeah.
So we're going this way, so we need to take 9 and divide it by the square root of 2. Those two problems right there should give you the exact same answer. The exact same answer. Okay? So, did somebody do it?
9 square root 2.
What's 9 to
6.4.
6.4. Here's the other thing that I don't know if you saw it up there. Do not round until the very, very end. So is it more than that?
Yeah, 6.36.
You got to use that entire decimal when you do your area now. So again, once I find that answer, which is 6.4, whatever, I'm going to take that times what? 12. Everybody good with that? And then you can round at the very end. What'd you get? Times 12.
76.4.
76.4. Everybody else get it? Or now we're doing it? Okay. Let's see if Gabriel's right. So again, some of these slides I don't like. See how they rounded? So their answer is probably different than your answer, Gabe. But again, our answers are all going to be the same because you're not going to round until the very end. And then again, if we go back to the problem, what should our answer say as our label?
Inches squared.
What? Centimeters squared. I don't know if that wasn't the right one.
Say
But in that, or whatever it is, just make sure. And again, if they don't give you a label, then we just say what? Units squared. Okay? Questions there? All right. Then we went to our triangles, right? So that, like I said, this was one of the triangles that they'll show. What am I going to use for my area? 12 and 9. Why would they give us all the other things? They would give us the other numbers if they asked us for the perimeter again, okay? If you're asked to find the perimeter again, you would not use the 9, okay? So we do 12 times 9 divided by 2 to get my area, right? Everybody all right with that? Hopefully triangles aren't real confusing for you. Same difference. Oh, I want to definitely go over one of these. The height of a triangle is 12 inches more than its base. The area of the triangle is 560 square inches. What's the base and the height? So again, I'm going to start out by writing my area formula for a triangle, right? Base times height divided by 2, or 1/2 base times height. Okay, so now you got to go back and you got to read it again. The height of the triangle is 12 inches more than the base. So basically, why I can't just use this is because I have way too many, what? Variables, right? So we know what this is. We know that this is 560. But even then, we still have a B and an H. And you can't have them with two different variables. You got to make one of them into the other. So with the information that we're given, which one are we going to make what?
How you do the H plus 12?
So how are you going to write it?
B plus 12 times B.
So I'm going to turn this into B plus 12. Everybody agree with Brandon? And now that's an H. But notice we just have B's in our problem. So that's good for us. So how do I get rid of this 1/2? I'm going to multiply by 2, right? I'm going to multiply by 2 on both sides. So 560 times 2.
1,200.
And then what do I do with my B?
Distribute
I gotta distribute this b through there, so I get b squared plus
12b.
12b. So, if I have b squared, what should automatically jump into our minds? I either gotta do the quadratic formula, or I gotta bring everything to one side, right? And I'm going to try to factor it. Okay? Or I do my quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is what Gabriel was talking about yesterday with this ax squared part, right? This is a, this is b, and this is c. Okay? So again, totally up to you how you do it. If you like to factor, you try to factor. Now obviously 1120 is a little different, right? Okay? I don't know if you can factor it or not, honestly.
So what if you need two different equations out of it though? So just combining them into one.
How are you gonna make two different equations of it?
B plus 12 equals 560, and then B.
But b plus 12 is not equal to 560.
Okay.
That's why you can't make two equations. Okay? So by this, I would say it's probably b, right? 40 minus 12, or 40 minus 28 is 12, but I don't know that for certain. Maybe it's d. I'm eliminating a and c, because if I subtract those two, I don't get 12. You understand what I'm saying?
Yeah.
So it could be D or B, right? Because they both equal to 12. Then you just have to check it out. But that's why I don't like multiple choice problems, because you can basically use what they give you. I can eliminate two of them right away. Kind of cheating the system, right? Okay. So is 28 times 40 1120? 2, 3,
Yes.
is 26 times 38, 1120?
No.
There's my answer. My answer's B, and I didn't even have to do it, right? That's why it's,
Oh, yeah, so you just.
that's why multiple choice to me is
Awesome.
cheating in math. No, it's not awesome, because you don't have to do anything. But does everybody understand this part of it? And then you just do the math. Okay? This is the important part, trying to set that up. Okay? All right. Then we go on to today's stuff.
So that learn how to wait.
No, I already learned.
So here's my trapezoid. So again, obviously, everybody okay? Somebody said it, maybe not in this class, maybe in the other class. The biggest other thing that you got to make sure of is that your labels are always the same. So notice here, 3 centimeters, 2.5 centimeters. If one of those are meters, then the first thing you got to do is convert everything into the same thing. Okay? So, we're going to take this and plug it into here, right? Whichever one you like to do. Everybody okay with that? You need to see the math. This one's really easy because of 1, right?
Oh, that's.
So the same thing right here. Now we kind of go backwards, right? Find the area of the deck. So, here's a question. Can I figure this one out? Don't say anything right here. Let everybody have a chance to think. Miguel designed a deck shaped like the trapezoid shown below. Can I find the area? Can I do that?
Yeah.
Because why?
Make a triangle out of that.
Yeah, out of the 5 and the 4 foot, you're gonna get.
Okay, so if I make this triangle right over here, I'm sorry, this isn't going to be straight. Okay? And I know that I have those two things. What do I need to do?
Find the bottom side, subtract it from 9.
Right, I need to find this little section right here, right? Because if I eliminate this section, that's going to give me my other what?
Oh, yes.
My other base up here, right? So basically I don't have b sub 1, right? So if we do this as 4 right here, what's this? Pythagorean triple. 3, right? 3, 4, 5 is a Pythagorean triple. So if this is 3, what's b?
6.
No, 6, right? b is 6.
Oh, yeah.
3 and 6.
Okay? So then we would use 6 and 9 as our two bases, and my height would be 4. Okay with that? And then obviously my answer is going to be feet squared. So what's 6 plus 9? 15 times. Now here, you can divide whenever you want, so I could take 4 divided by 2 and just get 2, and then I get 15 times 2, it's 30, right?
Yeah.
Okay. Everybody see what I did there? So again, it doesn't really matter when you divide or use that 1/2 portion.
So how'd you find that as 3? How'd you find that as 3?
Because I did this Pythagorean theorem. A squared plus 4 squared equals 5 squared.
Why'd you double?
But Kyron knows that it was a Pythagorean triple, so this is 3.
Why'd you multiply it by 2?
You took 9 minus 3.
No, then I took, when I knew that this little squiggly part was 3, I took 9 minus 3 to get my 6 up here. Okay? That makes sense now? That was a pretty good problem, though. That was fun. Right?
Sure.
Here's my kite. Find the area of the kite. So all I'm going to do is what in this case?
20 times 12 those.
Right. So again, this is where I'm going to divide by 2 right away to the 12. So I'm going to take 6 times 7 is 42. So again, you don't have to wait to divide by 2 at the very end or multiply by that 1/2. Right? I'm just trying to make the math easier, right? So do I have what I need in this case right here to find the area of a rhombus?
Yes.
Yeah, because really all I have to do with my 7 is what?
Double.
Double it, and then with my 9 I have to double it. So I'm really taking 14 times 18 or 14 times 9. Right? Again, all I'm doing is I'm deciding when I'm going to divide by that 2 or multiply by that 1/2. If that confuses you what I'm saying to you, then just do D1 times D2 and then divide by 2 all the time.
Can't you just take 7 times 9?
Oh, gee, 1/2 of D.
No, I can't do both of them.
You did 1/2 of D.
Right. I either have to do 1/2 of D1 or 1/2 of D2. I can't do 1/2 of both.
Okay.
So like Brandon just asked, I can't take 7 times 9. It's either 14 times 9 or 18 times 7. I can only do it once. Okay? And again, if that confuses you, you just do D1 times D2. I don't know if there's... So this is kind of the same thing here that we did with this problem right here. Okay? One diagonal of a rhombus is half as long as the other diagonal. If the area is 64, what are the lengths? So basically, with this one right here, you end up having 1/2 times d over 2 times d, and then divided by 64. So you end up with 1/4 on the bottom instead of 1/2. Okay? Again, hopefully that's just kind of simple math. And then don't be shocked that if you have to go in reverse order, right? A trapezoid has an area of 210 square yards. Find the height. So basically, we're just working backwards now, right? So again, this is where some of you don't like to write things down, but again, I would always start out with this, 1/2 B1, B2 times my height, and then I'm just going to fill in things, right? Well, now they tell me I have my answer. So 210 is equal to 1/2 times, and then I have my 2 B's, but I'm looking for my H. So again, that helps me just so I can see what I'm actually going to do. Some of you try to do that in your head, and then you get lost sometimes. Okay? Because we know what's inside some of your heads, right? So are we good with this math? The first thing I'm going to do is multiply by 2, and then I'm going to divide by this number, this total number. Okay? So we get what, 420? Is equal to 70H. So what's H? 6. 6 what now? Yards, right? So we go back to a height, and then you just have to use the number again. Or sorry, the label. Don't square it. The only time it's squared is when I'm talking about the area. Okay? Questions here? All right. So, if you want to do some problems, now you got to write down 2, or if you want to take a picture, take a picture. That's totally fine. We'll see. Tomorrow, we might break this one into two things.
Probably two fixed terms.
Yeah, so we'll do check for understanding for just section 1 tomorrow. Bless you.
That's this one?
Just section 1, yep, just this one. And then we'll do, the other check for understanding for the second section on
So
Monday.
you give us the homework for section 2 tomorrow. Essentially.
No, because we'll have another section tomorrow.
But,
So we're just skipping the section.
No, I'm gonna give you that homework right now too.
oh,
But that check for understanding won't be till Monday,
I didn't know you were giving us the second.
okay? And then we'll have a circles formula tomorrow too, for assignment for circles tomorrow. So this is just section 1 right here. So again, this will be check for understanding tomorrow. The second section is right here. And these problems we'll do on Monday. What? And then the circle ones we'll do on Tuesday.